All right, in this first topic, let's talk about what matrix addition and matrix subtraction is, and then I also want to talk about what our parameters are. There's a little bit more when we add and subtract using regular numbers. It's pretty straightforward. Like, you can add or subtract any numbers that you want, and it's not quite that straightforward when it comes to matrices, because a matrix can come in many different sizes, and not all sizes work together. So let's take a look at our canvas over here to see some examples of that. So I have 3 examples of matrices, A, B, and C. They're different matrices than in the last lesson, but I have labeled them A, B, and C again. If you remember, we do dimensions of a matrix according to, like, we're making an L, right? We go down and over. That's how we decide on the dimensions. This first one is a 3 by 2. Our second is a 3 by 2 as well, and then our last is a 2 by 3. So I forget, but I think we did the same kind of idea in the last section. So that probably looks familiar. Okay, adding and subtracting matrices. We want to ask ourselves, what are the rules? What are the parameters? I mean, we understand addition and subtraction. How is it the same? How is it different with matrices? So let's start by talking about if I were to add matrix A and matrix B. And the way that I would write that symbolically, the simplest way, is I'd just say capital A plus capital B. And that is the simple way to tell somebody how to add the matrices without having to write all of the numbers out every time that you talk about A plus B. Now, what would that mean symbolically speaking? Well, we'd be adding a 2 by 3 matrix to another, or sorry, not a 2 by 3, a 3 by 2 matrix to another 3 by 2 matrix, which, not surprisingly, is going to give us another 3 by 2 matrix. And the way that we do this, probably, I'm guessing, if you had to guess, this is how you would guess. There's nothing extremely unusual about how we add and subtract matrices. We just take the element here that's in the top left corner of A and the element that's in the top left corner of B, and we add them together. 3 plus -7 would be -4, and we put it in the corresponding spot of A plus B. And then we do that for each element, each pair of elements. So -2 and 4, we add those together and get 2. Then we go to the 2, 1 position. -1 and 1 makes 0. 2, 2 position, 0 and -3 makes -3. 3, 1 position, 0 plus 10 is 10. And 3, 2 position is 5 plus 6 is 11. And that's it. That's all it takes to add matrices. Subtraction is almost exactly the same. I'll do it in green. So if I wanted to say, maybe let's do B minus A, just to switch it up. We could do A minus B too, but let's say B minus A. Now, of course, in subtraction, order matters. Again, just like in our first example, we have a 3 by 2 matrix and a 3 by 2 matrix, and so when we subtract, we're going to get the same size matrix. And we subtract element by element, kind of pairing up the numbers. So it would be B minus A, so I look at the top left corner, -7 minus 3 will give me -10. And then I continue to do that for each pair of elements. 4 minus -2 is 6. The second row, 1 minus -1 is 2. -3 minus 0 is -3. Third row, I look at the position 3, 1. 10 minus 0 is 10. 6 minus 5 is 1. And that's it. So addition and subtraction of matrices is just that simple. Now the question that you'll be asked from time to time, just to make sure that you're paying attention, would be something like this. Somebody might say, can you find A minus C? Tell me what that equals. And the answer that you would give is, this does not exist. I'm just going to write no right now because that fits in there better. This does not exist. Now take a minute to look at matrix A and matrix C and think about why I might say this. Why does A minus C not exist? Well, A is a 3 by 2 matrix. C is a 2 by 3 matrix. They're totally different dimensions. So if I go to try to pair up the elements to add or to subtract, I won't be able to do it because like I could pair in the first row of A, I have 1, 2 different elements, but in the first row of C, I have 1, 2, 3. So obviously I'm not going to be able to pair it. So what I want you to understand out of this is it's okay to answer that there is no answer in some of these questions. There will be questions in your homework or in the packet that will deliberately ask you to do something that's impossible, and at that point it's okay to say there is no solution. So the main caveat in this case is if the dimensions are not the same, you can't add or subtract matrices. So that's our first topic. In the next video we'll look at equality of matrices and how that relates to matrices of equal dimension.